All right, good evening, everybody. Innovations in science, technology, engineering, and math are needed if America wants to maintain its competitive edge. What does that mean for Purdue and the future of our students? More importantly, what does that mean for the future of our nation or even the world? Are we challenging students to think about learning in terms of what already exists, while at the same time pushing them to explore what doesn't? How can we find a way to teach the ways of the past to give them a foundation for the future and still integrate the vast amount of new technology available into our education system? This issue is a balancing act, and one that no institution has found the answer to yet. In 1965, Gordon Moore, a co-founder of Intel, made an observation in an article in an electronics magazine, noting that the number of transistors in a minimum cost integrated circuit had been doubling every 12 months, and predicted that the same rate of improvement would continue into the future. But this observation later led to Moore's law, which states that roughly every 18 months, technology doubles and the price to produce this technology decreases. Well, this could explain why some students at Purdue are feeling a bit shortchanged after they graduate. Meaning the technology that they use in class and laboratories are becoming more and more outdated, and therefore hindering their preparation for joining the workforce. Now let me explain that Purdue does an excellent job at instilling the fundamentals of the sciences behind the technology in its students. The fundamentals like physics, thermodynamics, math, and chemistry is just to name a few. But without this valuable knowledge, the person running the equipment is merely just an operator. I'm talking more about the difficulty to keep up with the increasing amounts of technology that's being utilized by the modern day technologies. These ideas relate directly to what's going on at Purdue. However, they can be translated to apply to most universities. When Purdue was founded in 1869, the university never stopped working to enlarge the function and development of the different departments. But since the technology department was founded in the 1920s, the technology department has worked to keep up with the technological advancements of the world. In 1965, Gordon Moore, a co-founder of Intel, made an observation in an article in an electronics magazine, noting that the number of transistors in a minimum cost integrated circuit had been doubling every 12 months, and predicted that the same rate of improvement would continue into the future. But this observation later led to Moore's law, which states that roughly every 18 months, technology doubles and the price to produce this technology decreases. Well, this could explain why some students at Purdue are feeling a bit shortchanged after they graduate. Meaning the technology that they use in class and laboratories are becoming more and more outdated, and therefore hindering their preparation for joining the workforce. Now let me explain that Purdue does an excellent job at instilling the fundamentals of the sciences behind the technology in its students. The fundamentals like physics, thermodynamics, math, and chemistry is just to name a few. But without this valuable knowledge, the person running the equipment is merely just an operator. I'm talking more about the difficulty to keep up with the increasing amounts of technology that's being utilized by the modern day technologies. These ideas relate directly to what's going on at Purdue. However, they can be translated to apply to most universities. When Purdue was founded in 1869, the university never stopped working to enlarge the function and development of the different departments. But since the technology department was founded in the 1920s, the technology department has worked to keep up with the technological advancements of the world?
One way we would like to illustrate how the rapid change in technology impacts students is to explore the evolution and educational influence of 3D printing. What is the purpose of 3D printing? The purpose is to transform a computer design model into a physical solid model. The first 3D printer was created in 1984 by Charles Hull. This technology was also known as stereolithography. Hull's company, 3D Systems, created the first commercially available 3D printer in 1992. Currently, Purdue has two Objet Eden 350 and one Objet Eden 350V 3D printers. Both units print in high-quality modes. So what is the cost of 3D printing? The cost is based upon the amount of material used by weight, typically 10 to 20 cents a gram depending on the type of material used. As you can see, once an institution purchases a 3D printer, the cost to sustain the technology is relatively inexpensive. That was a quick review of the 3D printing. Let's now talk about how we can apply this technology into the educational field. Currently, students at Purdue are using 3D printers in classes like ME 444, where students are using 3D printers to create tools with movable parts such as adjustable wrenches and ball bearings. Now that you understand a bit about 3D printing and how it works, we're going to talk about how we can apply the technology in the educational field. First, please give a thought to what the 3D printer can do, which is transform a computer design model into a physical solid model. One big advantage of this is incorporating 3D modeling and the ability to create a scaled model, thus attempting to integrate and run a system before building a full-scale system, allowing students in the university to save money and resources. For example, students in the hydraulic engineering use 3D printing technology to make a scaled drainage model of a city to test if it can meet the needs to drain water off the ground effectively and efficiently. It can prevent some expensive mistakes which otherwise would not be found until after the system has been built. Another benefit of 3D printing, like other types of technology, is the ability to improve the efficiency of the education afforded. For so many majors, such as engineering and architecture, students need to use physical models in order to increase their understanding of the system. In some instances, students spend, or rather waste, a lot of time creating a physical representation of their concept, which is time that could have been eliminated or reduced by utilizing a CAD simulation or 3D printing instead. Try to think of those same students who are equipped with a 3D printer. What are the possibilities then? At the very least, they could save 2/3 of the manufacturing time and focus on the design process utilizing their specific CAD program. The 3D model could be colored using different materials to provide different colors for the model, thus better representing the desired product. The visualization could be greater than the prototypes shown in the blueprints or the poorly manufactured handmade models. This sounds pretty good, right? A 3D printer could do much more than this.
Dr. Marlo Steed teaches new media and technology in the Faculty of Education at the U of L. He recently purchased his 3D printer and has been exploring its potential classroom uses.
Here at the university, one of our mandates is to explore and research various possibilities that will enhance education and learning for students in the field. And then to share those possibilities with our students who are prospective teachers, to give them a vision for what is possible.
Hello everyone, I'm going to introduce some specific examples and the personal experiences that I have. Okay, first let's talk about the personal experiences. I was designing a large capacity drum magazine for assault rifle when I was in the aerospace engineering major in the CUC. At first, I thought it looks amazing, but after I finished the structural design, I realized I couldn't afford what it would cost to make a prototype. It would cost me about $7,000 to get a CNC mode. Finally, the Rapid Manufacturing Center at the Civil Aviation University of China was able to help me out. They were able to purchase a powder sintering 3D printer, which would only cost me about $600 for the prototype. So I conducted the testing on the prototype and collected data from the experiment, of course. After testing the product, I found some components worked well, but someone did not. I used that data to make changes to improve the data and the overall product. I think the 3D printer helped me to have a deeper understanding about the design process and how to redesign a product after the experiment on the prototype. Technology can be applied over a vast range of departments. Using our example of 3D printing, we can see that this technology is applicable to fields other than engineering. Biology professors can use 3D printer to make a model from nature, which can be difficult to see and understand in our daily life. Let me give you an example. An anthill. There are older methods of modeling this, but these methods lack scaling and detail. One way that an anthill could be molded is by pouring liquid metal into the anthill, and after the metal hardened, there would be a full-size model of that. You can imagine it's pretty big, However, but by using 3D printing, we can more easily create a scaled-down model of the anthill without destroying and use less resources, right? This would also allow the model to be easily transported, be handled, and examined. Another example is about the people born blind, and they have a difficulty conceptualizing what something is without feeling it, since they must use their fingers to see and create the image in their minds of the object. For example, a blind person can hardly be able to understand how large an aircraft carrier truly is, right? They may be able to go onto the ship, but they physically cannot see how large it is. But if we are able to put the scale 3D model of the aircraft carrier in their hands, what's going to happen? They can feel the model and conceptualize that they are feeling and truly understand how large an aircraft carrier really is, right? 3D printing can be utilized to create models for blind students and people so that they can see things by feeling them with their hands. It's much more convenient than ever. A huge part of what we know and what we will learn is based on history. If we can find a way to better understand the history, then we can have a better create and innovate in the future. If students can re-engineer something using 3D scanning, then what can happen? I think they will have gained much greater knowledge of the part of the system than simply studying it. Let me give you an example. The faculties of the department, in the mechanical engineering technology, have access to 3D scanner that is being used for research, but this technology is not available to students using their classes or laboratories. Try to think if this technology were more accessible, then students would be able to think even more out of the box. 3D printing have a huge potential impacts on many different industries, such as motor vehicle, consumer products, business machines, medicals, academic, aerospace, government, and military, right? And then let's take a look at what impacts will the new technologies have on Purdue education in various departments and fields. Thank you.
Seeing the technology that Purdue has utilized in the past 50 to 100 years, and knowing the impact that Moore's Law will have on technology in the future, we see now more than ever how important it is to give our students the tools to make them successful in the workplace and inspire them. Purdue realizes that importance and is working to improve itself because of it. And our own Purdue president, Mitch Daniels, stated in a forum held in November of 2013 that the university has plans to expand its engineering college. And in the process of doing that, we will become even more differentiated as one of the true STEM capitals of American higher education. All this will be done in order to improve the quality of our innovation, which President Daniels says is directly tied to the diversity of the people who sit around our table. The leaders in the 21st century need to be able to think critically and creatively and work part of the team and be open to new technologies and their uses. From teaching tomorrow's teachers to understanding the nuances of each technological challenge, universities must focus on incorporating, improving, and shaping the future of technology and its uses. Education must prepare tomorrow's technologies leaders by teaching them skills for a successful career and inspire them to solve the global challenges of tomorrow. Thank you.